Hi, good morning, and welcome to this Food Sense webinar. So at ZP, we like to do this Food Sense webinar once a week, and it's really just, oh, sorry, not once a week, this is once a month. This is a more intense discussion and demonstration of the Food Sense. Now, the Food Sense, and today we are sponsored by our Indian distributor, Technando. So if you're in India and you're interested in testing chili powders, etc., then please reach out to Technando. Um, if you want to follow on with this, when I say follow on, if you'd like to follow these demonstrations, when I say these demonstrations, what I'll do is I'm just going to change cameras just for a second. And I'm slightly wave my arm around in front of this camera and kind of say, we're talking about Food Sense Generation 4 today, and we're going to talk about testing chili powders, chili sauces, chili oils, Malaya resins, fresh chilies all crushed up, sauces, etc. So we'll be talking about doing chili sensing. The reason I've changed cameras just slightly, and I'll go back now to my original camera, is because if you want to follow on or we want to start engaging with this technology, you will need the Food Sense Generation 4. So let's not be in any doubt that you'll need the Food Sense Generation 4. But if you want to understand how this technology works, then we do have something called Julie. Julie is a cloud system. So if you end up becoming a client of the Food Sense Generation 4, when I say a client, I'm just reaching out now, actually just grabbing a manual. It's probably worth saying, I mean, this manual is not thin because it's lacking detail. It's actually really a really nicely laid out, well illustrated manual and it talks about where to get the app from in the manual. It talks about how to start up the unit. It talks about how to log in. Talks about how to upload your data, etc. So it's all in the manual, let's say. But one of the things that it will tell you about is there's a cloud system called Julie. If you register on Julie, it will ask you for your email and it will ask you to create a password. So that gives you a Julie account. That Julie account works with a app called Sense It All. So Sense It All, it's a little bit, the sort of name says it in some ways, but the app is what drives this assay. So I'm going to hold up to the camera now my phone, and on my phone you'll see it says Sense It All, and it says chili sensor, for example. So if you ever want to follow along this webinar later on and just have a little play with the technology, you will actually need the hardware to truly play with the technology. But just to give you a sense of what's going on here, we have a cloud system called Julie. Later on, if you do your chili testing, all your data, including the time, date, and operator, is all saved into Julie. And and if you then install the Sense It All app, so if you scan this QR code from an Android phone, it will install a app. If you log into that app using your Julia credentials, then the app and the database are synced. So first of all, you open up a Julia account, email and password. It's your email and you create a password. Then you log into this app using those credentials, and now those two things are synchronized. If you're using an iPhone, there's also a QR code for the iPhone as well. So we obviously support Android, and we also support the iPhone as well. Now, these QR codes, if I just hold my app up to the camera for a second, there's a little button here. If I click this button will now want to scan a QR code. I've just scanned a QR code, and now I want to do chili. So the app, if I do ginger, now the biggest user base of this, now I've just scanned the QR code for ginger. The biggest user base for this Food Sense Generation 4 is definitely people doing chili. I'd even say it's as much as 99%, but we do support other tests as well. It's just, this is a sort of direct recommendation from me. Buy it primarily for chili because that's where most of the customers are, but we do have other analytes on the platform as well. So Food Sense Generation 4 really offers a kind of a rapid test. It actually offers a much more competitive cost per test. And it also, when I say cost per test, I mean, this is relative to HPLC. We do a lot of work, for example, with companies, and the cost and turnaround for getting an HPLC test, including India, for example, it doesn't matter though if it's India, USA, or Europe, the cost per test by HPLC can be very expensive. I'm not entirely certain. For example, I know in the US, the cheapest you can find it is $50. It's much more typical that somebody will spend $100. It's like 100 euros in India. I'm sorry, in Europe and in India. I also believe it's sort of in the tens of dollars as well. Now, what the Food Science Generation 4 does is does an objective test, and I'll sort of explain what I mean by that objective test. Well, but what it means is you'll get a number on your phone, and you will also get the raw data saved in the cloud. This is an interesting point. See that people at the moment they either not testing at all, or they may on occasions do an HPLC test, and when they do an HPLC test, they send it out, they get this what's called certificate of analysis back. They just get this number, but there's no, let's say, scientific evidence behind that number. There is actually something called a chromatogram behind that number, but very rarely people ever receive it. But with the Food Science Generation 4, you get the number, good, write it down in your quality records, and you get a raw signal saved to the cloud that you can look at later on. It's also got traceability, and what I mean by traceability is time, date, who did it, raw signal, and value are all saved in the cloud. So, you don't go wandering around wondering where your data is. It's actually all saved in the cloud. So this really plays a really good role in what I call IQC, PQC, so incoming quality control. So if you're receiving materials from another company, you can do an incoming quality control. If you're trying to process chili powder into a chili sauce or a layer resin into a chili sauce, you can actually do process quality control. Or if you're trying to ship product out, you can do an outgoing quality quality control. So we have tested lots of products, including some of the, if anyone's ever watched Hot Ones on YouTube, where they get often US celebrities to eat increasingly hot sauces, you'll actually find out that ZP has actually been the company quietly testing those hot sauces to make sure that the claims are, let's say, correct. What I'm going to do now is I'm just going to change cameras for a second, because the reason I want to do that is because I've sort of talked in the theoretical, but you're actually going to receive a couple of demonstrations today. I've got my colleague Solron online, but before I go there, I just want to make some backups on some of those claims that I've just made. So I have a sample here. This sample is under 1 in 10 dilution. I'll explain that later on, but I just want to make sure that we do understand, that actually, when we say, it's quick to test, put a sample on like that. I go to assay. I just go back, so I actually want to just give this a name. Right. I just want to do that because otherwise we can spend the next 30, 45 minutes talking, and then at the end of it, you'll get a demonstration. But I just want to kind of demonstrate to you immediately what we're talking about here. I've got a meter. Sometimes online people call it this kind of Scoville meter. We have an app, and the app is driving that meter. And at the moment, I've got this progress bar running, and I've got a result back here that says 5,730 Scoville heat units. So I'll hold that up to the camera now. At the same time, you may hear me typing, because what actually I'm doing is I did this demonstration quite spontaneously. So I'm just very quickly logging into a database called Julie. So let me just do that as well in parallel with this. Right, so I'll just change camera just very quickly, which is here. So you get a result there and then on your phone. So that is a simple interface, and you saw how quickly that kind of, I was able to demonstrate that. What I want to now do is just share my screen for a second. I've come slightly, I wouldn't say off script, because we don't script this, but I just wanted to kind of give you a quick look into this, because what it's actually done now is it's actually sent the data to the cloud, and I can actually see now the meaningfulness of this raw signal will be explained in a bit. But this is the traceability claim. This is the bit that's very different, that so many times either there's no testing at all or it's HPLC testing. And if you do have HPLC testing, it costs you time. It took time and it costs quite a considerable amount of money. And you may only get the Scoville heat unit. But here we've actually got the Scoville heat unit. That's what I was showing on my phone. It's saved. It saved the time and date. So I can see, the date here, the 1st of August, the universal time up here. I can see my raw signal, and I will explain what that raw signal means. You don't need to understand that raw signal, but you will be interested to kind of know it. And I can see the results here. And then, I see these very distinct fingerprints. So there's absolutely no doubt this is capsaicin. I mean, can you imagine being able to sort of otherwise just generate these, these raw signals? Now, the meaningfulness of this will come along in a minute. What I'm going to now do is I'm just going to go back to the, let's say, the main presentation. But I just wanted to explain what I meant by that term transparency. Transparency, you do the test, you get the result on your phone, you get everything saved to the cloud, and traceability, you saw it, all the details are saved up in the cloud. Now, what's really kind of nice about this, we've tested things like spicy mayo, so hot sauces. There's a company in the UK called Nando's. Chili oils we've tested, chili honeys we've tested. The Bomb, if you ever watch any kind of YouTube, like I say, the Hot Ones YouTube channel, I think the last sauce they tested is the Bomb, and we've tested that. And Extreme and chili powders, and we've also tested things like ginger as well. I think what makes the Food Sense Generation 4 quite different is its speed of sample preparation and the range of samples that we generally can test. I would say that I think depending on region, so in Australia and the US, maybe people are testing the either chilies themselves or chili sauces. In India, it seems to be much more chili powder. So different regions, different sample types. Just a brief introduction to ZP. I mean, today from ZP side, there are 3 of us, myself, Solran, and Niti. We also have Aftab online today as well from Technando, who are our support and frontline distribution in India. But ZP, we were launched in 2014. We are ISO 13485. So means we're basically certified to do medical development or the development of medical products and assays. We've got a quite diverse team. It's probably worth talking about support. Support is something that we're pretty good on that. And I want you to know that, and it's important, if you actually do buy one of these and you get the unit, as soon as you get the unit, the manual itself is, as I say, I've already waved it, is actually quite, it is intuitive. I know it's intuitive because one of these arrived in the US the other day, and I can see already that people have created an account, etc. So the manual's pretty good, but the first thing you should do if the unit arrives is make sure that you booked your online training, because there's nothing worse than somebody running 40 samples and it's not happening, let's say, and they need training. So make sure you book your online training as soon as it arrives. We do weekly webinars, so if you have a technical question, then we address them in weekly webinars. And then we have these monthly webinars. These monthly webinars might be useful because in any company there can be a certain turnover of people. So if you then need somebody to receive like refresher training or introduction to this technology, you can always know that, well, at least once a month, when that new starter comes in, they can, join one of these webinars, get trained up, etc. It's probably just worth saying that at ZP, we've recently been helping some people with chili powders. We've ended up having to write, no, not having to, but, we wrote them a special SOP just for them, so that they could get the best out of the system. So that's kind of, I think if you talk to Aftab, you'll find out that what ZP is really good at is actually that support element. And it's not, it's quite deep support in terms of, we have a lot of PhD type chemists who can really understand capsaicin. Now, it's probably worth saying that this is not this is a product that's been on the market for quite a few years. This is the first generation 1. You may sometimes see some old videos on YouTube about this. This is generation 2, generation 3. the product's got better over the time, and now the one that we're really interested, or the one that we're really proud of, is this Generation 4 product. So what we'll be demonstrating today is Generation 4. So Generation 4 is definitely smaller than its predecessors. It's definitely easier than its predecessors. In fact, when we do some more demos in a bit, you'll just see how quickly we can load up sensors into this and start running the unit. I mean, that easiness is also displayed in this video here, because I had a couple of engineers in the house with me, and they've never been trained on it. They're able to run the unit, and they're able to run the unit because they've heard me obviously talk about this a few times. But it's intuitive enough that, you know, even very young engineers are actually able to use this unit and get meaningful results out of it. Now, admittedly, they're working together in that video, but I'm really sorry if you can't run this unit. I'm sorry, it is simple. It's more accurate than its predecessors. And that accuracy in part comes from the fact that we can see the raw data. So we can troubleshoot so much easier. You know, if somebody didn't put a sample on there, we'll see it in the raw signal. And I'll make some errors in a bit. I'll do a special demo where I actually make some deliberate errors, and you'll be able to see that the app can spot it. So it is cloud enabled. It can do multi-analytes. Chili is by far the biggest application, and followed then by Ginger. But we do have some things like total antioxidative capacity. As I say, the hardware on this Generation 4 is very elegant, easy to put in sensors. The fact that we've got this kind of cloud connectivity really helps with the support. So all that data that you gather, it all goes into that cloud system. ZP can't see that data, which is not a bad thing. What do we mean by that is it's your data, it's protected. If you choose to share it with us, we can then also look at that data. And, you know, when we're trying to help people understand their signal, you know, then we can, it's good that we can look at the data. For example, I think one of the situations you have is that actually people are receiving a chili powder, and you say, what's your expectation? And they say, oh, it's 90,000 Scoville heat units. What they've really done is they've Googled it, you know, so they have no real evidence of what the genuine hotness of that chili powder is, for example. And so when they then test it and they actually found out that it's, you know, 40,000, they're like really shocked. And they're like, no, but it's not right. It's like, no, just because you got that number off the internet. But of course, because we actually have the raw signal, we can generally say, no, look, the raw signal is not lying to you. You know, there's the number, there's the raw signal, you know, and we can look at the raw signal and see that there's been no sort of errors in the measurement. Now, when if you in fact if you open up the box, inside the box we have a manual. The manual's super easy. I'm starting to find that once upon a time I thought we'd have to give everyone training, but most people are now spontaneously actually just opening up this box. The manual is thin because in fact the system is quite easy. I mean, there's only one button on the system, that's basically on off. You know, so it does really help. So the manual really helps guide people through the experience. It tells you where to get the app from. That's that QR code system that I was talking about earlier on. It tells you how to turn on the system. We put an on-off button on there just so you get that sense that, you know, is it on, is it off? But it's got all these LEDs that actually kind of guide that experience. So, you know, it is clear to you. And you also get the chili sensors with it as well. And you also get 500 mils worth of buffer. So we talk about diluting the samples, and so we give some buffer in order to do that dilution as well. And these are the chili sensors as well. As I say, you can actually get this app off the Google Play Store or the Apple App Store. It's probably worth saying it's very tough to actually get it's very tough to get onto the Apple App Store. So you have to put in quite a lot of effort to make sure that your app is of the right quality. And as I say, you can go between different analytes using that QR code. So sensor goes into the meter. The app tells the meter what to do. The app runs, we get the data, and we actually send the data to a cloud system where it's just permanently stored. And if later on you can log in there and you can see your raw signal, and you can You can choose to, if you wish to, share it also with ZP as well, only if you want us to kind of basically support you or etc. Now, I'm going to dig a little bit now into the science of this, because when you see that raw signal, we're not asking you to look at that raw signal, by the way. You can, and I'll hold it up again, you can get a result there and then on the phone, for example. And that's nice and simple. But there is a raw signal, and the raw signal for capsaicin is very distinctive. So we can see that it's capsaicin, and then we can also so just out of interest, fresh green chilies are fine. There's never any doubt about this system, because in fact, if we test a fresh green chili, if you test the fresh green chili, you will see what its cyclovoltammetry looks like. So let's now talk about the actual science of this. So this originally the original invention comes from the University of Oxford in the UK by a guy called Professor Richard Compton. The source of the hotness in chilies, whether they're fresh green chilies, red green chilies, chili powders, is capsaicin. Capsaicin, you'll see this now in our raw signal. You'll see that we get one peak. So that's peak one. That's the first confirmation that this is capsaicin. This is the second peak. Here it comes. Boom. And then on the third scan, sorry, on the second scan, there's another peak. So you get 1, 2, 3. Here it comes now, scans. So that's the fingerprint for capsaicin. The height of these signals tells you how much capsaicin is in there. I'm just going to go back to that data I gathered earlier on. So when you look at my data from earlier on, there's what we call peak 1, there's where we call peak 2, and there's where we call peak 3. So let's say Richard in his lab at the University of Oxford, did the original assay, and even today, that demonstration that I just gave you just then, there it is, exactly the same. Except what have we done? We've actually converted this signal into Scoville heat units. So in fact, we're sort of, we're taking it all the way. What do these peaks mean? The only reason I'm going to explain these peaks is because one day you may be, people may ask you, well, what does this mean? Okay, well, look, this is what peak 1 means. This is capsaicin. This is the molecule that I think it binds with a receptor in the mouth called TRVP1, and that gives you the sensation of hotness. But this is capsaicin. We're using a technique called electrochemistry or cyclovoltammetry. We oxidize it on the electrode, and that gives us what we term peak 1. So I'll just let this this animation come to the end, and there's a question here about the aster color value. First of all, we can test or layer resins. Sorry, so there's some questions coming through the line, but this is what gives to peak 1. Now, a layer resins we can test. A layer resins are quite intense with the capsaicin, so you end up doing quite a lot of dilution on them. And then the aster color value, I think, is quite interesting because we're using a smartphone. It's obviously got a camera involved with it, so there is a possibility that we could actually extend the app to actually do the color evaluation as well. But let's be very clear, we haven't. So you've really asked 3 questions. Can we test fresh chilies? The answer is fresh green chilies, yes. Then one of the other questions is, can you do a layer resins? Yes. And then your other one is, can we do the aster color value? And the answer is no, we haven't. But we do actually have the capability, and I've a few times asked myself, should we do it? So I think the answer is at the moment not. But because obviously we're using the phone to command the Scoville meter what to do, and we're using the phone to send the data to the cloud, we could have actually extended the app to also include photography, but we haven't done it at the moment. Now, just to go back to the main thrust of this webinar, this molecule capsaicin that we're detecting, once we've oxidized it in our test, it actually undergoes what's called hydrolysis. And it's that hydrolysis that then gives us what we call peak 2. So we've got what the highest value the instrument can measure is 60 million Scoville heat units, which is basically neat capsaicin. So there we go. So that's what we call peak 2. So there's the peak 2 there. And now I'm going to explain this peak 3. So this is the fingerprint for capsaicin. So peak 1 is the oxidation of capsaicin. Peak 2 is due to the hydrolysis of capsaicin. And peak 3 is due to the oxidation of what's called a quinone. Oh, sorry, quinol back to a quinone. And that gives us what we call peak 3. So if you're ever doubting, that you've got capsaicin in your sample, you definitely should be able to see these 3 peaks. So there's peak 2 just appearing now. And then if we just wait about 5 seconds, 5, 4, 3, 2, 1, there is peak 3. The only reason I show all that is because if you look at when I did that test earlier on, I got those 3 peaks, and I said, I will explain that actually those mean something. These are the 3 peaks for capsaicin. You do not have to understand that part of it, but it does help you understand that, let's say you had green chili, and in fact, you were doubting. If you do green chili and you do the experiment right, you should get exactly what we're showing here, because that is the capsaicin in that green chili, let's say. Same for the Olea resins as well. I'm going to, depending on the hotness of your product, we end up recommending different dilutions. So if you're about 5,000 Scoville heat units, which I doubt you will be on the green chilies, then it's 1 in 10. With a green chili, I suspect you'll do what's called a 1 in 100 dilution. There's some few questions here yeah, 4 to 5 million lac SHUs. Yeah, so I get the point. So I think there's a question here. Can we do Olea resins at 4 to 5 million Scoville heat units? So, for example, your 4 to 5 million is what we call 400,000 to 10 million, for example. So there you do a 1 in 10,000 dilution. And what I'm going to do now is I'm going to do a quick demo. So I'm going to stop sharing my screen for a second, because I'm going to make a deliberate mistake. I just want you to see this, let's say this deliberate mistake. So let me just change cameras for a real quick second here. Yeah, you can see that. What I'm going to do is I'm going to take a sample, and I'm going to do what I call an under dilution on this. So I'm going to take this sample, I put it into a vial, then I'm going to just dilute it with a very little amount of buffer. Right, so I've just done a very, very mild dilution of a sample. I'm doing this to create a deliberate error. Let's imagine that we were trying to do Olea resins, for example. Right. What I'm going to do now is I'm just going to vortex this really quickly. So that's now homogenized that sample. I'm going to put a fresh sensor on here. So let me do that. Right, sensor goes on. Right. Now I'm going to put the actual sample, I'm going to put the sample onto the sensor, which I will do now. Now this is deliberately being done in such a way that I'm actually going to get an error on this, but I want to show you the error, because so let me put the sample on here. Right, so sample's gone on, so it was quick enough to prepare that sample. I'll go done. I'll call this tab 7. Go to assay. What you should notice how quickly actually I can do the analysis. Let's say there's no way that it's probably quicker to do this analysis than it is to pack a sample into a box and send it away. It's much quicker to do this analysis and send the sample off to the HPLC lab. So here it goes, run. By the way, things like Olea resins are slightly Olea resins, for example, are actually slightly easier because they're very kind of So what it's done is it's given me this this error. I did this on purpose. What it says is too high, dilute more, upload complete. Right? I've done that on purpose, but I want to show you now what that really looks like, especially if you're using these samples that are maybe more rich, let's say in capsaicin. So what it's done is I can now go to the I just want to share my screen, sorry, real quick. So what it's done is I've still got the let's say the raw signal, but the raw signal now, when I look at that, see that is very intense. If I look at the signal from before, this is the first experiment I did. This is like 10. Now I just made that deliberately, let's say, enriched sample. That signal is now at 20. And the app has told me that I've basically got too much capsaicin in there. It said too high, dilute more. So what I'm going to do just very quickly is actually do what the app told me. I'm going to just do a quick dilution just to show you that how we can cope with that. So I'll take the sample. I'm going to put quite a lot of buffer into it just to dilute it down quite a lot. Something I've not actually talked about is the app allows you to tell the app how much dilution you did. So it back calculates the number. So I'm just going to dilute that down, which I just did. That's actually quite a lot of dilution. Just vortexed it really quickly. I've just put a new sensor in here, which I'm now doing. And I will do a quick I'll do a quick test on that, which I will now do. Sample goes on, I go done, just give this a quick name, 8. What you'll notice is that everything I do is actually all being saved. So, you know, I don't even have to make a conscious effort to actually save this. Just out of interest, if you've got a choice of dilutions here. I mean, at the moment, I'm just doing a quick dirty experiment, but you can sometimes you'll do what's called a 1 in 10 dilution, sometimes a 1 in 100 times, sometimes a 1 in 1,000, sometimes a 1 in 10,000. The reason I bring that up is because you've got those dilutions available to you, and you choose the one that you actually used. And then what it will do is it does the back calculation for you. So depending on the dilution, it's not telling you the Scoville heat unit of the diluted sample, it's telling you the Scoville heat unit of the actual, let's say, sample. So again, these assays only take about, I think, less than 60 seconds, in fact, to run. I think even in this little webinar today, I've done something like 3 tests already. So what you'll notice now is it has given me a number, and it hasn't said to me, you are in error, because in fact, now I've got the dilution correct. So you've got to understand there's an AI running on this system that actually looks at your data and advises you what to do. And then if I just share my screen for a second, traceability is all up there, because in fact, here's my new data. Look at that. I'm back in that 10 range. I can see the result up here. I can see all the results here. So there's an amazing amount of traceability in this. Now, rather than just me monologuing at you now, what's going to happen now is I'm going to hand over to my colleague, Solrun, who's going to do some more testing for you. And I'll try and read through some of those questions that are also being asked at the same time, because questions are coming through at the same time that we're talking. So thanks, Solrun.
Hey, so yeah, my name is Solrun, and I will do a quick demonstration on a powder for you, because now Martin has done some tests on sauces. So I will test this powder, but I've already teased it. I have already weighted it out. So you can see it here in the bottom of the vial. So this is a total of 0.01 grams. So we expect this powder to be very pungent. That is why we want to make a dilution ratio of 1 to 1,000. So with this being 0.01 grams, we need to add 10 grams of the buffer, or 10 milliliter. So that is what I will do. I will add 10 milliliter of the chili buffer, just like this. Okay, so I'm adding it in. Just like that. And now I will vortex it. So as you can see with Martin, like you see now that the powder is on the bottom. As you can see with Martin, like the test itself is actually quite quick. So sometimes it's the preparation of your sample that takes time. So I will just vortex it, and it's a convenient way of getting a homogeneous solution, as much of a homogeneous solution as possible. But what you will see is that for powders like this one, there's quite a lot of chunks and bits, and you will also see that with sauces. But with these powders, there are particles, and they will fall down to the bottom, which is okay. It's the capsaicin is being extracted up from those particles into the solution. So do not worry, even though you don't have a homogeneous solution, that you have this precipitation or heterogeneous solution. So now we've mixed it. So what we will do now is we will add sample to the sensor, and I will actually show you the app. So here you can see the Sensible app, and I've already chosen the chili sensor assay. I can do it over again by clicking that button next to the chili sensor. So if I click that, we'll start scanning the QR code, and I'll scan the QR code just like that, and then it chooses the chili sensor assay. We can also change the test settings by just clicking that box. So I'm just calling this sample for powder, just so that it's easier for me to find that data later in my cluster. So I will click go to assay, and what is very convenient is that you have an instruction guiding you through what to do. So as I said, we will use a dilution ratio of 1 to 1,000, just because we know already that this is pungent. Martin was going through how to sort of figure out what dilution ratio to use, and also we do have some calculations that makes it easier for you if you know the expected range of your school heat units. So what I will do next is so I'll show you the zoom in. So here's a sensor. So I will place and lock the sensor cartridge in the device. So it's very convenient. If you look, you see 3 pins coming in, and the design of this device is made for the lab. In case you spill, like, you won't ruin any of the electronics, and you can just easily take it out and clean it, and contaminations won't be an issue. So there's much thought into the design of this device. So what I will do next now, as you can also see from the app here, is we mix the sample, and now we will add 50 microliter of the sample to the sensing area of the sensor. So that is what we will do next. So I'll take a pipette, and I will pipette 50 microliter of this sample onto the sensor. So just like that. And you will also see that some particles will get onto the sensor, and that's also completely fine, especially with way more chunky samples than this one. You'll see a lot of them, but again, it's the it's the buffer part of the solution that that's being tested. So then we'll click Start Measurements. And then I'll show you the progress bar. So right now it's just a simplified view of what's happening. So it's just showing a progress bar, but what it's really doing in the background is it's going through that cyclic voltammogram that Martin was showing you with the peaks appearing for capsaicin. And it's also sending the data to our on-cloud platform, Julie, where it's analyzing the data and sending it back to the phone. So now it says results are too high. It says dilute more, and it also says upload complete. So let's take a look at what's happening in Julie. So that's one of the strengths with Julie, is that we will we can see what is actually happening to our sample. So I just need to hit refresh, and here powder appears, and you can see our data, our first scan and our second scan.
Yeah, I mean, you've got the same as you've got the same as me. You've got that when you're on that first scan, you can see that first peak was like at like 20.
Yeah.
So it's exactly what I had. I wouldn't bother to optimize it during the webinar because I know you can now do a sort of further dilution, but don't do it because we'll be starting to optimize it now. But that's good because in fact,
but it still gives you an indication though in what range you find the sample. And here you see that it's 1.1 million Scald heat units, and this is in fact Carolina Reaper. So we would expect it to be fairly high. So next time we should maybe dilute it even more, as also the app is saying.
Great. So I think that's the so those are the demonstrations today. So thank you for that Carolina Reaper demo. I wasn't expecting that. That's pretty good. I'm just going to change cameras for a second because I realize I'm using that camera. So I think today we've demonstrated a very mild sample from me, which was really more like sort of 5,000 Scoville heat units. We showed you the speed at which we could do it. We also showed you that, in fact, if we haven't done enough dilution on it, the app has got an AI working in it, and it's actually looking at that and saying, no, you need to dilute more. And rather amusingly, with Solron's example there, she was actually testing quite a pungent pepper, so a chili powder, and it's actually told her to do a bit more dilution. So it works in real time, let's say. So I think I can think that we could definitely make the statements that this is fast, it's much lower cost than HPLC. It's pretty smart, and it's got great transparency. You get all that raw data. You can see us looking, but you also get, you get that number, but you get that raw data as well. And you also get that traceability because in fact the username the time, the date is actually all saved up there. We've definitely done green chilies. We've also done Olea resins. We've also done chili powders. I was doing a chili sauce today, so it's got quite a breadth of capability. So I think with that, we're just coming up to 1 minute. So we've got 1 minute left. So I just want to do a quick thank you for this. I appreciate Aftab from Technano has joined us today. So if you're in India and you're basically interested in engaging with this product, then please don't hesitate to reach out to Aftab. You register today, we'll send you a recording shortly. So as soon as this video is processed, we'll also send you a recording. Now I know that Niti, Solron, and I unfortunately do have some meetings now, so we're going to jump into those. But special thanks to Aftab and a special thanks to our guests this morning for attending. And have a good rest of the day, guys. Okay, thanks very much.